Hi, my name is Kristabel Kontá, and today I'm going to guide you through the process of meiosis. No, not mitosis. Meiosis. Meiosis, which will help us get 4 haploid cells from only 1 diploid cell in the course of only 2 divisions. But first, let's make sure that we really know what haploid and diploid cells are. Haploids have chromosomes staying on their own, while in diploids, the chromosomes are paired up. In order for us to divide a cell, we first need to make sure that the same genetic material would go to both daughter cells. This is possible through replication, in which we get 1 more of each initial chromosome. Okay, but where exactly is the chromosome then? The pair of 2 X's is called homologous series, which contains 2 chromosomes, each X. And this X is formed by the original and the replicated chromosomes, called now sister chromatids. If we zoom in one of the homologous pairs, we can observe quite a phenomenon. Sometimes the ends of the sister chromatids might overlap and exchange genetic material. This process is called crossing over, and it happens during the first phase of meiosis, prophase 1. But what else happens during prophase 1? Well, in addition to the crossing over, we can see that the chromosomes condense and become visible. At the same time, spindle fibers start forming from the centrioles. During metaphase 1, the homologous series line up at the equator and the fibers attach to the centromeres. We would have observed crossing over already, and now it is time for the random orientation. During random orientation, you really don't know which chromosomes would line up, so you don't know what you would end up in the end. Shortly after that, anaphase 1 is conducted, during which the spindle fibers shorten, pulling the paired up chromosomes apart to the opposite poles of the cell. And after that, we observe telophase 1. This is when the parent diploid cell begins the process of division and nuclear membranes start forming around the separated chromosomes. Lastly, cytokinesis takes place, during which the diploid cell finally separates, producing 2 haploid cells with full nuclear membranes. And after that, well, it happens again. We have prophase 2, during which the nuclear membranes break up and spindle fibers start forming once again from the centrioles. Then we observe metaphase 2. This is when the chromosomes line up at the equator and the fibers again attach to the centromeres. At anaphase 2, the sister chromatids are separated and pulled to the opposite cell poles. Again, you never know how did they align during metaphase and which chromatid would go where. During telophase 2, the cell starts forming nuclear membranes and has almost reached separation. In the second cytokinesis, we are presented with 4 individual haploid cells having half the number of chromosomes of their parent.